Welcome to our world. Welcome to WorldServe.
We thank you for purchasing the RoboX kit from WorldServe. Before you begin, we advise you to go through all the instruction videos provided by us. This would ensure your safety and at the same time make sure you understand the correct procedures to be followed while assembling the kit. Failure to follow these instructions may result in damage of the equipment and/or injury. This video explains stage 1 of assembling the WiRo, that is, building the rover. Before we begin, we assume you have viewed the unboxing video before starting this stage. If not, please find the link on this screen. This video can act as a guide for those who are interested in building a chassis-based robot as well, so please do watch. Let's begin. The first step is to take the chassis out from the box and also remove the various components provided in the chassis kit transparent cover. This will make it easier for assembling the rover. At this point, you should have all the contents of the screw kit, 2 motors, the tires, and the omnidirectional wheel ready for this stage of the assembly. Keep the screwdriver handy as well. The L293D board shall be used later in this video. Next, take the T-junctions provided and peel the brown stickers on both sides. Failing to do this will prevent the T-junction from entering the slit provided on the chassis. Once complete, place the chassis in front of you as shown and the RoboX sticker faces upwards. Now flip the chassis around such that the RoboX sticker does not face you. Cross-check the orientation of the chassis. It must match the orientation in the video. Next, take one of the T-junctions and insert the same into the slot provided. Take another T-junction and hold the same in the groove parallel to the previous T-junction inserted. Now take one of the motors and slide the same into the gap between these 2 T-junctions. Before doing so, make sure the wire ends of the motors are pointing left. Make sure the holes found on the sides of the motors align with the holes of the T-junction. Now take one of the long screws and insert it into the motor via the T-junction. If done correctly, the screw must pass out from the motor through the other T-junction. Use a nut to secure the screw. We can tighten this later. Proceed to repeat the same for the other hole as well. In order to tighten the screw, hold the nut with one hand and use the screwdriver to tighten the screw from the other end. Do this for both screws. One motor of the chassis is ready. Now repeat the same procedure for the second motor. Confirm the direction in which the wires are facing. They should point to the narrow end of the chassis and should be similar to that shown over here. Continuing to keep the chassis flipped, pass the wires of the motors through the holes provided next to it. Do this for both motors. The next part of the assembly is the omnidirectional wheel. This will be fixed to the narrow end of the chassis, which will also be the front end of our rover. Take the omnidirectional wheel as shown and pass a small screw with a flathead through one of the holes. Rotate one of the spacers on the other end of the screw. Do not tighten them just yet and leave them loose as shown. Once you're done fixing all 4 screws and spacers, locate the 4 holes on the chassis where the omnidirectional wheel will be fixed. Place the omnidirectional wheel such that the spacers align with the holes and flip the chassis. Now take 4 more small flat-headed screws and pass them through the holes on this end of the chassis, in turn securing the spacers and the wheel. You can now proceed to tighten the screws with the screwdriver. Flip the chassis once again and tighten the screws on the other end as well. All the wheels are now successfully fixed to the chassis. You can now take the tires and secure them via the holes to the motors. In case the wheels come off during running the rover, you can add a drop of glue inside the holes and fix them firmly to the motors. It is now time to make the chassis you have built to move. Until advised, do not connect the power bank. Connecting the power bank before the connections are complete can lead to injury. For making the rover you built to move, you will need the L293D board, which is found in the chassis kit. As mentioned in the previous video, there are 2 variants of the board. In one variant, the USB cable is already connected to the power supply pins of the board and is glued. However, in another variant, the USB cables have been provided separately. In this case, the USB cable must be first fixed to the L293D board. Before doing so, let us have a quick look at the L293D board. First, locate the 5V voltage regulator, and keeping that as reference and at the top, you can explore the various parts of the L293D motor control board. At the center of the board is the heart, the L293D motor control chip. To the left and right of this chip are 2 pairs of connectors to which we shall connect the motor wires. On the top side of the board are a set of 5V and ground pins which shall be used to give control supply. Further to this, at the bottom of the board are control pins which have to be powered in a particular combination to make the wheels move. Finally, right next to the 5V voltage regulator is the power supply connector. It is marked with a positive plus and a negative minus sign. Make sure to observe the same. Individuals with kits with the separated USB cable can now take the cable, identify the positive wire, which is usually red in color, and insert the same into the positive plus terminal of the L293D board. You can repeat the same for the negative wire of the USB cable, which is black in color. Do not interchange these wires. If unsure, talk to a supervisor, teacher, or parent. Interchanging these wires can lead to severe injury. Also, never remove these wires with the power bank attached to the USB. In case you remove these wires with the power bank still connected and the loose wires touch, it shall create a short circuit. This can cause the power bank to heat up and might cause injury. Tighten the screws and give the wires a tug to make sure the wires are in place. Those with the variant with the glued wires, do not tug the wires. Please do check if the USB cable has been correctly connected to the power terminals and not the motor terminals. This is a common mistake. Next, let us connect the motors to the motor control board. After placing the chassis as shown and also the L293D board, screw in the wires of the motors in their respective motor control terminals. The motor to the right can be connected to M2 and the motor to the left can be connected to M1. The polarity in which you connect the motors decide the direction of the motors. You can interchange these wires later on in case the wheels are not moving in the direction intended. You can give a small tug to the wires to make sure they are securely connected. Let us now give the necessary control signals to make the rover move. To do this, take 4 female-to-female wires from the set provided. Female-to-female wires can be identified by the absence of pins on both sides of the wire. Next, identify the control pins at the bottom of the L293D board. Connect the first control pin to 5 volts on the board. The second pin must be connected to ground. The third pin should be connected once again to 5 volts. Finally, the final pin of the control must be connected to ground. Cross-check and verify all these connections. If you've cross-checked and verified all connections, it is now time to connect the power bank to the board via the USB cable. As soon as you connect the same, you shall see the rover moving straight in the direction of the narrow end of the chassis. In case any of the wheels or both wheels are moving in the opposite direction, interchange the wires at the motor terminals in the L293D board. Do this disconnecting the power bank. In case you see that only one wheel or both wheels are not moving, have a look at the motor terminals first. You can see in our case, one of the wires connected to the motor terminals from the motor was cut. In such a case, disconnect the power bank and screw back the loose wires. Sometimes, the rover might not move at all even if the motor wires have been inserted correctly. In such a case, check the control signals and whether they have been connected to 5 volt or ground correctly. In our example over here, all the pins are mistakenly connected to ground. On rectifying the same, the rover shall move. The control signals also might be mixed up, so it is better to have a check on the control signal side as well. In rare cases, even after performing the above checks, if the rover doesn't move, check the power bank, nano and L293D board for heat. In case anything is warm or heated up, immediately disconnect the power bank. Heat indicates there's a short. In such circumstances, you can redo the wiring and check once again. In case the heat persists, exchange the components with the spares given. Be careful while handling the L293D board as it has sharp edges at the bottom side. Also, make sure you do not place the L293D board on the screws of the omnidirectional wheel. This might lead to a short. On successful connections, the rover shall now move straight ahead. We hope this video was helpful. Before you move on to the next video, please do not forget to like the video and also please do not forget to subscribe. Details on how you can procure the RoboX kits have been given in the description of this video. Thanks for listening, and you can now move on to stage 2 of making the WiRo.